Hi, this is Professor Cummings, and I have another video here, and this is going to round out my playlist for derivatives. So far we have the power rule, the quotient rule, or excuse me, now the quotient rule, the product rule, and I already did a video on the chain rule. So I wanted to get this one video out, or get this one created, because it was one of the videos on my list that I had missed. And this is, as I said, the quotient rule. So what this is another rule in finding a derivative. And this one, similar to the product rule, you actually have two or more functions, but instead of it being the product of two or more functions, this one is the derivative of the quotient of two or more functions. The product rule was the product of two or more functions. This is the quotient of two or more functions. So you can see here I wrote it in two different formats. The first format here is f of x over g of x, taking this derivative. Taking the derivative. And this other one, the derivative is represented as the derivative of u over v with respect to x. Same statement, same basic statement, just written in two different formats. As you can see, the way it's a little bit more complicated than, or maybe equal complexity as the product rule, but you have a standard form that I want you to follow, and it can be confusing to look at because within it, much like the product rule, you have a combination of the original functions and the derivative of those functions all the way throughout. You can see it a little easier in here. You got, if we take the second format, you've got v times the derivative of u over x minus u times the derivative of v with respect to x, all over v squared. And the way to remember this, and I saw this on another YouTuber, and I realized it was actually a very clever mnemonic device, low d high minus high d low over low low. So let's look at it this way. So you've got low, meaning the denominator, the lower portion of the quotient. So low, and the derivative of the numerator, d high, minus high, the numerator, and the derivative of the denominator, low, dv over dx, over low low, meaning the denominator squared. So again, it's a nice little mnemonic device that you could remember when doing the quotient rule. But remember, you're dealing with the quotient. You're taking the derivative of the quotient of two or more functions. So let's go ahead and look at this a little bit more. Move on to an example. So here we have, again, the quotient rule in standard form. And again, remember the video on the power rule. The power rule is the more fundamental derivative that we can work with here. If you know the power rule, you can do all of these a little simpler, right? So again, it's the power rule. If you have a function x to the n and you want to take its derivative, you take the exponent as a coefficient of x and then subtract 1 from the original exponent. So we can do that, and we can apply that to the quotient rule. You'll see how, just like with the product rule, it's easier just to go ahead and do all your derivatives of all your terms beforehand and then apply them to that standard form. So let's look at this example. And you're going to remember this mnemonic device down here at the bottom. So we got a function here. Again, x squared plus 1 divided by x to the fifth. So let's walk through this. So again, we know we have low d high minus high d low. We're also going to need the derivatives of both of these functions. So high is x squared plus 1. So the derivative of that, again, remember, just using the power rule on each term, sum of the derivatives equal to the derivatives of the sum. So take the derivative of everything there, and you'll end up with just 2x. So now we have to take the lower term, which is x to the fifth, and its derivative, again using the power rule, 5x to the fourth. Take down the exponent, make it a coefficient, and subtract 1 from the original exponent. So now we have everything we need to use the quotient rule. So now we need to just put it into its standard form, substitution into standard form. And so we have it color-coded here, low d high, the derivative of the high term, minus high d low, the derivative here, over low x to the fifth squared. So this is the derivative. So right here we've actually done the derivative, but now you have to simplify it. So we've got this in the derivative, so just simplify it to something a little more useful. All I'm going to do is carry out the arithmetic. So we got 2x times x to the fifth, which is 2x to the sixth, minus, multiply 5x to the fourth through, which gives you 5x to the sixth plus 5x to the fourth, over x to the fifth square, which is x to the 10th. Simplify it a little bit further, and we have negative x6 minus 5x to the fourth over 10, or x to the 10th. And finally, we factor out an x, or x to the fourth, and we end up with a much simpler version of this. But we've actually done the derivative at this point. Now we've got it simplified down at this point. So again, this is Professor Cummings, and I wanted to go ahead and comment if something's not clear, subscribe to the channel, as well as share the video to people who might need help with. Know that a lot of people are getting ready for their next semester, getting through their classes, and the reason I do these videos is to be more helpful to people as they go through their studies, or just as a refresher for people who might need some help. So go ahead and share this, and be back for the next video.